Yeah, Liam.
Never been to a calculator.
I don't think they're gonna have one. You have batteries?
I don't think it's batteries. Sometimes, some days it works, and some days it doesn't.
Okay. You can use, mine's on the back shelf there. Go grab it right now. Okay, so has everybody got that? Does anybody not got it so I can move on here?
I don't have it. Oh, I know why. I didn't check the maximum of my y.
What's the answer?
1.771. Okay. You good, Lauren? All right, so when we did this in Applied, this is how we solved it. We solved it using the calculator. Now what we need to do is we want to be able to solve these questions and do it without the calculator. Well, sort of. Without graphing it, let's put it that way. Now, one of the things that we learned in Applied is how to do what we call change the base here. All right, change the base to a logarithm. So to rewrite this as a logarithm. So to do that, actually I'm just going to change this to y here. And change this to b. Okay, so I have b to the x. So y equals b to the x. So before you could do the inverse, you would just switch your x and your y, and then you'd have to bring the y down. So let's switch my x and y. So I go b to the y is equal to x, like that. Now what I need to do is take the log. I'm going to bring this down to here. Y equals. This is my base. When you talk about an exponent or a power, that's my base, that's my exponent, right? So that's my base. So I rewrite this as log base b to the x. Okay? So y equals log x to the base b. Now, what we learned is we are trying to change this so that our calculator can solve this for us in base 10. All right? We're trying to change the base so that the calculator can work for us. So you need to go from here to here, and from there to there. And it's a simple process. To go back, I take this to that exponent equals that. B to the y equals x. Bring the y down, log. Bring the b down to the x. So this reads as log x to the base b. Okay? What it's doing is it's going to allow us to solve something like this. So I could take this down, bring the x down, equals log of 7 to the base 3. So far, so good? Now our calculator can't figure this out for us. So what we're going to do is we're going to change this base so they're both base 10, which is what our calculator does. So to do that, I just simply go log 7. If there's no base written in, it's 10 over log 3. Punch that into your calculator using your log button on your calculator. Log of 7, close bracket, divided by log 3. Same answer? Yeah. Okay, great. Okay. So this is where we're heading. To do this, what we're trying to do is, can we solve questions in which the bases are not the same and cannot be made the same? But to begin with, you start with questions in which we make the bases the same to solve them. So look on page 261. The first question is 3 to the x equals 81. So your first goal in mind, your first thing that you want to try and do right now is make it to the same base. So what can 81 be written as? 3 to the power of 4. So therefore, what does x equal? 4. Right? If the bases are the same, and both sides are equal, then what does that mean about the exponents? They have to be the same. Correct? Okay, so let's look at the next couple here. So I have, I see what you were saying. Sorry. Okay. So they want you to check these answers to make sure that they're right. So this guy, does 36 to the 1/2 equal 6? Yes or no? Yeah? Why? Give me 2 reasons.
Because the square root of 36 is 6.
Because 1/2 is written as a square root. So what's the square root of 36? 6. What's the second reason? Can I make 36 to a base of 6 somehow? Yeah? So what is 36? 6 squared. Would you agree with me?
Yeah.
The 1/2. What's 2 times a half? 1. They equal each other. Okay?
So this is rewriting in exponential form?
Alright, so, sorry, I'm just butchering this because I'm going on all kinds of tangents. Let's try this again. This time I'll do it correctly. It says, change the form of an expression. For each expression in exponential form, rewrite in logarithmic. So I need to change this. 3 to the 4th equals 81. I want to change it to logarithmic. So to do that, the exponent comes down. You write log on this side. This stays as 81. This goes down to my base. So the log of 81 to the base 3 is equal to 4. Got it?
I have one question because when we were writing down like how to do it, we have y on the other side equals to
Which was
y.
your exponent?
I thought that was that.
No, I changed it for the second one.
Okay.
For this one. So from here I went to here, not from up there.
Oh, okay.
Okay? Okay, so let's try this next one then. 36 to the 1/2 is equal to 6. Okay? How do I rewrite it? Bring the half down. Log 6 to the base 36. So far so good? Okay? So next one. The next one we got to go the other direction. So log 125 base 3 equals, no,
Base y.
base 5 equals 3, right?
Yeah.
Okay? So all I do here, take my base and move it to the other side. It still stays as the base. So I get 125 equals 5 to the power of 3. Is that right? 5 cubed 125? Yeah. Alright so far? What was the last one here? Log of 10,000 equals 4. What's the base in this question?
1.
10. It's not written in, Lexi. It's always 10. Okay? So, what does 10,000 equal? My base, which is 10 to the 4th. That's right. Okay? Alright. I'm just checking to see where we want to go with this. Evaluate each expression. What does it have here? It has log 32 to the base 2. Okay, and it wants us to evaluate this. Alright, so one thing I can do. Okay, I'm going to show you 2 ways. One's going to be a little ways down the road. One's going to be fairly simple. Let's let it equal x. So I let it equal to x. I can't do it this way. Let's change it to exponential. What is it? If I change it to exponential, what does it equal?
2 to the power of x equals 13.
32 equals
2 to the power of x.
2 to the power of x. Can I change 32 to the base 2?
2.
2 to the power of what?
5.
What is it?
5.
5. So what's the answer? X equals 5, right? So far so good? Okay, I'm going to show you 2 quick things, and then I'm going to let you work. We also did some rules for logarithm. Being applied, there were 5 rules that we did. When I took the log of a number to the same base, what did it equal? 1. Very good.
I just guessed.
Why'd you have to just ruin it for yourself?
Because
We give you all kinds of props and then you just went and ruined it.
I had to be honest.
Okay. The other thing we do is if you have the log of a number to an exponent, we move the exponent to the front of the log. Okay? So it looks like this. Log 32 to the base 2. So I want to get this to be the log of 2 to the base 2. So to do that, this is 2 to the power of 5. Agreed? You agree?
Mm-hmm.
Okay. One of our logarithm rules was take that and put it at the front. So that gives me 5 times the log of 2 to the base 2. Lexi, what's the log of 2 to the base 2?
2, 1.
You almost, and then you take it away. Equals 1. Okay, go to work on that, please. Oh. She's not in this class. No, she didn't. Oh, okay. Alright, where's 5? Okay. So basically today all you're going to do is work on 8. Were there issues with 7? Stop it. You had a couple questions for